Rare and unstable isotopes are emission. Additionally, with these isotopes, we also have neutrons, muons, pions, neutrinos, and also gamma rays. The quantity of these particles, the abundance of them in these secondary cosmic ray showers depends on their intensity, their altitude, and their energy and angle distribution. So, you might be asking what is the point of detecting cosmic rays? Because apparently radiation from secondary cosmic rays is one of the main sources of natural radiation exposure to people, even on the surface of Earth. Even though even though it is non-lethal, but for people that are living at higher altitude or work in higher altitudes, such as flight crews or people living on plateaus, they are more exposed to harms of radiation because of these secondary cosmic rays. Scientists have been trying to study and assess the level of danger these radiation from these rays have on human health. So, this is the main equipment of this payload. So, this payload is another point of this payload is a diagnostic tool for the algae payload. The aim is to detect and study radiation from the shower of cosmic cluster. To measure radiation, we used a novel and inexpensive radiochromic film, also dosimeter film, and it will be launched in two different looking payload equipments. One is a capsule, and another one is a frame. These films were developed last year within the MEBAR lab. The longer this film is exposed to radiation, the darker it becomes technically. So these are the two parts of this payload. The external payload, also I call it the capsule, and the internal payload, which I call it the frame, simply enough. The capsule is designed to be hanged from the parachute rope, and it will be fully exposed to the outside of the rocket once the parachute is deployed. And fortunately, it has been designed and light enough to not cause any strains or any issues with the parachute process, within the recovery process. How it is designed is that the dosimeter film is supposed to be slide into the window right over there, and it will be fastened into the bottom of the payload, bottom of the payload. The second part is the frame, which is going to be fastened on top of the payload bay beneath the nose, and this radiochromic film is going to be measuring the radioactivity from inside the rocket, and with a dimension of 40 by 40 millimeters. So, one way that this project is going to be useful for the future is that it can give many preliminary information for the design and development of dosimeters for aeronautical application within aerospace, such as radiation detection for astronauts when they're in space. So, thank you so much for your attention.
Any questions? Thank you all so much for your time.
Okay, thank you, Arbalest. We are looking forward to seeing your post-flight video of dynos happily glowing from their successful launch. I worry a little bit about Syed wearing sunglasses. Hopefully it isn't because you've made the dynos too angry. Our last presentation before our first break is from McGill Rocketry. Our presenter is Esteban, who will be telling us about the team's latest, most powerful, and most ambitious ambitious engine. And in particular, the presentation will highlight some of the strategies that were used to overcome various challenges that were encountered while preparing for hot fire test. So please welcome Esteban to the stage.
Slides on the screen. Awesome, thank you so much. Good morning. I hope everyone's doing well on this lovely, rainy Timmins morning. So today I'll talk quickly about scaling solutions for rocket engine testing, and particularly in the context of my team's experience. So to start off a bit with our team's background, the full design parameter of 110 kiloseconds. And then on the left of the picture, we have what we call our bench scale engine, which is a much smaller version of Hurricane that I'll talk a bit later on in our slides. So now a bit about our own team's testing philosophy. So obviously high power engines definitely increase the risk in case of a failure. In a small test rocket, a small failure might be almost without any consequences, but with such a large engine, any sort of failure would potentially bring quite a lot of destruction and a lot of infrastructure risk. More propellant also significantly increases the per test cost. So as you might have seen, the price of nitrous oxide bubbles has risen so much in previous years. So that's another big challenge when we're dealing with our limited budgets. And finally, also at McGill, we have a context that is together into our large-scale hot fires. So I'll talk quickly about our test step. So for larger engines, we definitely required some upgraded testing capabilities. That starts off specifically for a hybrid engine with a larger oxidizer supply system that needs to be able to give out more mass at very high
This thing is so inefficient to do on this group.
Right there.
Sorry. We're gonna leave the motor part connected because it's full of hot glue, so I'd rather not damage those from this glue. And we know that those are secure, so. Yeah.
Watch out.
I'm gonna put them up there.
What's up, chat?
So the safety inspection is pretty much a review of your simulation, basically. The safety inspection is pretty much a check if any fault or activity.
Yeah. He did check in the two walls, though. He saw sus activity.
Where?
They don't choose to check everything. He looked in it. He saw the nose cone. That sus area.
We don't need to show it anymore. We're not turn on it. We're not gonna turn on it.
How to test it? Are we locking it or no power? No power?
No, but you need to
Just keep it for the fun of it.
No, let's take it out, bro.
Alright, fine.
We go higher. We go
Yeah, I'll run the mass budget. I'll run the mass budget.
Is it a good thing to go higher though? Like I think if we wanted
Well,
to
no, we
stick
have
with
to hit our altitude. Instead.
Yeah.
Right now we're overweight.
Yeah, we're overweight.
We're not hitting the altitude. We lose points.
Yeah, this is like 500 grams removed.
500 grams gone right there.
And the wires too.
And the 500 grams of 1 kilogram gone.
Oh, we don't need to use the wires. You
1
have
kilogram
You
gone.
have 1 kilogram of wire.
No,
That's great.
this plus the wire is 1 kilogram.
Oh, okay.
Can I get the Amazon version?
Also, we don't need this anymore, do we?
What? We're gonna strip it down, bro.
Well, no, I mean these are nice wires. We can use them for something else.
No, we'll keep
At
the
the very
wires.
least,
I mean, we keep the wires. Whenever we relaunching this on full
Full attitude, bro. We're going to Texas to launch it. With the N5800, we ball.
58.
Yeah, either shreds or gets blasted, bro. Notice how we also got we also got an solid, bro. Staying with also. Rough the last time, bro. The only thing I leave was hard in the field. Yeah, bro, Professor Vsauce.
Hey, yo, this is a dangerous position for this cable, Michael. We're gonna move it.
Michael,
because
lights come on, bro?
Someone tipped this over and your cable and your shit.
Live stream? Oh, chat was popping.
Bro, put the
Chat,
rocket
we
together.
passed safety, bro. We passed safety.
Dad, put the rocket together again, Dad. What is this? What's going on?
What's up?
That's unique looking camera right there. Lands well. Looking good. Proud of it? Missing your nose?
That's
Yeah. The nose content was done the label file.
Yeah.
That's how you do it. Go around chat. I think.
Oh, yeah, Michael.
Yeah, so it's a little bit off center right now. Actually, we should adjust it. I hate when people just do at the end top of the label, just do a full round.
Yeah. Bring the rocket.
Yeah, we re-rolled the whole thing. Okay, so
the whole team Goose rolling over there. What the fuck?
the
whole team.
That's a good. That's fiber job. It's very thin that one. That's a man.
Yeah.
And it's, I mean, it's just the Goose film, yeah, it is. A lot of news. It's
like on an app.
How to do it the best.
Very cool. Well, good luck, guys. Try it. And then go.
You guys have the details the same, you're just going to launch it, and I was saying some stuff like the injectors and valves, and also you touch them in project management, like delegate as much as possible, and don't try to fix everything, like you don't need to have everything upgraded to the very next location. You have to do what you can to the best of your ability. He wants some.
Where'd you get that? Was it ice cold? Loctite in or am I tripping? Who put this one in? I don't know. I never know. But if somebody screwed it in randomly, it's fucking goofy. If someone screwed it in randomly, it's goofy. Fucking cool. We don't know if this is Loctite is Where's Caleb? Did he go here? Where the fuck's Andrea? They're here though. Where? Is there Loctite? I never assembled that. Yeah, but it's like, it's the thing in the garage for that.
I don't know if that's Loctite.
Oh yes, it passed.
I like it.
It passed.
The fin was pretty solid.
They call this solid, Professor. I don't know.
Yeah, they call it solid. They like it.
So no questions.
No question. They're one. Oh, there was finger pointing at why our nose goes so heavy. They're wondering why it's so heavy.
What's so heavy?
That payload and
Payload. Why is it so heavy?
They said
Up on the avionics mask.
it's double the mass. No optimizer.
Ooh. Why is it so heavy? Oh, sorry.
That's why it's so heavy.
It's this thing down here, no?
Both of us. Both of us.
Yes. It's a good
Standardized
weight.
aluminum.
And that's at the front end?
Yep, right in the coat.
It's not gonna help you.
Yeah, so what they said is because it's so heavy, they're gonna start wobbling. And they're like, we already have problems with this coupler of that one.
If we need to, we can take this one off.
Yeah, so what they said is if need be, just take them out, take them out. This is like 500 grams right here.
This is all of Aussie's funding.
So ideally we keep this and we take this. If we have to. Ideally we keep both. Ideally.
We have options. But now we're gonna go make our propellant. We're gonna go load it up.
You get just, yeah, just that.
Oh yeah, we're being judged too. Judging the lunch. Yeah. Can we go lunch before it? Lunch. Lunch, bro, lunch. We just had breakfast, bro. Motor's gonna take an hour, bro.
Yeah,
The rain's off for 6 minutes, we'll go. We got chocolate.
rain is not Westbound.
Nice, so heavy. But aren't these, like, I thought these were like 3D printed or something, right?
No.
Those are metal.
Yeah, it's not like 3D printed, right? Yeah, that's why I found that one.
It's like a powder coating or something?
I thought about
This one's, I think, clear anodized. This one is blue anodized. And then the black anodized.
I mean, that looks like white stuff.
Yeah, it looks like 3D printed.
I thought it was like a powder coating that they applied.
They could run it.
But that doesn't matter. It's like the thickness of the walls. And
Yeah, it's way too thick. Like all of
yeah, it's this thing.
Oh, it's not that
It's
thick. It's
not
not
that
that thick.
inside.
holy shit.
Maybe it's like
Bro, this guy Nathan needs to go back to SolidWorks, bro. He needs to go back to the class.
SolidWorks, no.
Look how thick this plate is, brother. Like, no optimizing here.
This entire part is actually
Solid.
yeah, just solid bricks. It's not even hollow.
He got his 1 gram off here, 1 gram.
Yes, yes. The way we're leaving, yes.
expert mass optimization.
Double axle solar.
Okay, so you're flying tomorrow then? If the weather's right. Do they, what if it's raining? Do they have any rules around
Yeah, it's raining enough to
If there's like a sprinkle, maybe.
yeah. But they're gonna tell us in the morning.
Yeah, 7 a.m. sharp will tell us. Only the driver to tell
How
us.
will they tell you?
Only the driver.
That's a meeting.
When you drive all the way in?
Yeah, that's it.
So I'm told it's along, like, you can go down to Sudbury. What is that? 69?
Highway 144.
So it's down that highway?
Yeah, you go down the highway, then, in a random turn, you gotta turn right first. And then you start going on the gravel hill for like half an hour. I think.
I just send,
So it's in the bush, basically.
coordinate, yeah.
Yeah, it's in the coordinates.
Yeah, send the coordinate. Send the coordinate.
The road
Well,
are,
if you have a route, that's also good.
they said it's like better now, but they can still be walks and stuff. Yeah, you make sure you download your app.
Oh yes.
There's no service, the moment we enter for it. When we have like satellite texting and stuff, so
So that's like when we drive to ARM, there's just some random road on Highway 17 and it just came out. We go in for about a place. Yeah, there's a random road, you take that.
This is the road that we drive from the bottom to the campus. So this is the drive back. There's a map.
Is that much? You're still downloading part of the map? Is that right?
I think
You're downloading the map?
Yeah, it's a download.
Way more than that, right?
Yeah, if you can send it.
I didn't even come this way.
ASAP. We don't have to know what time to come in.
I'm going to try and travel with Robin because she's at the same time. I think she knows how to get out.
Yeah, to get there.
But in case.
There's a lot of people driving in and out. There's also a shuttle bus.
No, shuttle bus is
Shuttle bus is like an hour long.
But it seems like they were saying, like, in this bush, it's a lot more gravity, so that's why mosquitoes are more of a problem.
Oh, yeah, so
surface water.
yeah, it's really like this pond, not like, even last time my foot got wet, just stepping in a puddle, and the mosquitoes are bigger. They're bigger. They're scarier.
So yeah, it's different in that context. It's a lot.
These bugs have not, like these forests have not been explored, Professor. They're uninhabited.
Exactly. Yes, this is truly the forest.
Yeah, this is not the provincial part.
I think it's something about the geology in that area, like the rock here.
And this is what's it called?
Shield.
Yeah, it's really rocky.
Yeah, well, this whole area is supposed to be, I guess.
They pulled those
like
down.
lower elevation. Is there a river there? Like there's a couple of times where we go,
Yeah, we dropped
Be here. We're talking.
Go outside, bro. Go do it in the car. Get a vice too.
Yeah, I was gonna just clamp. I was just gonna clamp it, I think.
Clamp it to something. Cut it over the black line.
Huh?
Over the black line. On the higher side.
On the higher side of it? Someone come with me.
No, what's she saying? Take it. Yeah, Professor. I mean, we have our own radio. If you have one, you have your radio.
I didn't like in that car.
Oh, no satellite doesn't do the Professor.
Oh, you mean I should have investigated Rogers?
No.
Do you want Southwest Sonic?
Where?
Set up what? Sonic.
Bro, it's cooked right now. Oh, where the hell's on it?
Hopefully at the hospital.
Where do you go?
Hopefully at the hospital.
So where's anything left?
No, I'm going to the hospital. Alright, it's like double the size of
Bro, got like the rabies or something. Yeah, but
All
the whole
is good.
mosquitoes, like all of them. We go vlog?
Hey, but stay here.
Hey, we hold the fort now, bro.
This was here before, bro.
pretty good, but this guy's the one
Or you kill those 10 times they get back there.
Hey yo, what's up, chat? Let's go. This way. Which way are we going for?
Yeah, where are we going?
Where are we going, chat?
Yeah.
Something there, bro. Something there.
Chat, let's start with you. Flyaway rail guide? Is this custom made?
Yes.
Avionics?
Is it gonna work? Who knows?
What happened to it?
What happened to what?
What's not gonna work?
No, we'll see. We haven't tested the rail guy.
What? No Tesla?
Oh, it's gotta be first. What's up?
I saw their camera mount. It's really nice.
Ooh, where is it? See, they're putting a CG on. Where's ours, huh?
Yeah, bro.
Don't worry about it.
Look at the turn here. That's professional.
Professional turntable.
That's professional, bro. Left fin and both.
Oh, there, see that? You see that? They have the kind of a capsule for the camera.
We didn't mention our flutter.
Yeah.
G12 fiberglass body tubes. S-red bulkheads. Dual deploy.
Big improvement.
It's to scale.
Can I see your S-rat?
We have everything like built into the safety. We're just doing the safety sort of. I'm not like later, and we can get it up for you, but like.
What's that camera?
We just got our shit together for the safety.
We did too. We're done our shit.
Oh, you finished it? Nice. We're about to go. We're just marking the center of everything.
How long did it take? I guess it depends if you're ready. Yeah, I guess that's a good. Yeah, we're good.
Well, we didn't mark their CG. They asked us, we're just guesstimated.
Guessing.
Yeah. You have the motor. It's hard to guess.
We don't have a motor.
You have the motor. Okay.
We're gonna do
build an app.
Yeah.
What motor you guys on?
3400.
It's big one.
Our CGs are pretty low.
CG's easy. No one knows CP. Oh, Baraka says something.
How can you guys get this much? Four decimals?
Stock motor.
But yeah, I actually, what they just made, exactly. They're perfect.
Like what scale do you guys have?
Like a really, like a drug scale. Like it's exact. It's great. It's a mini scale.
You got what? 4 decimal blade black powder.
More significant. Oh. Yeah, so the green motor firing, toasting, drone, and then green. Yeah. And this is like the terrain it was on to scale.
Bathtub the hill.
Yeah. Remind me, where's Dalhousie?
We're in Nova Scotia.
Nova Scotia.
Halifax,
Yeah. I love the try.
You guys can build a mini rocket if you want.
Yeah, that's all.
Feel free to take first.
Yeah, we gotta go. Thank you.
This is the
the
ice
ice
cappuccino. Cappuccino.
Nice capsule, yeah. That's
S-Red flight computer. Radio transceiver.
Did you guys get free Tim Hortons from the photo shoot you did there? No. Bro. Couldn't even bring the rockets.
I love the edit of the first That's progress. Patch update.
You just like to take a picture for one.
No, that's proper. No. Proper patch update for update. He's four. I'm about the paint scheme. The fin counts on what's
Goose 4. Goose 4 Tuesday.
That's Goose 4 shot.
Goose 4.
Could we get one for a drop? Needs to be like double headers.
That 2 is big.
Analog, and then we place all our analog components on the bottom of the board and all the components on the top of the board. And so that basically removes the effects of coupling from the digital communication that you have on measurements, which you obviously don't want because the more coupling your analog lines, those are just that's what we did for display. And then for sensing information, we had someone from
Q4 nose cone. 14 kg. Holy shit. 50 kilogram dry weight.
Yeah, it's a chunky rocket. So we got like a decently powerful engine, but just like such a large airframe.
No way, the ours weighs 10 kilograms less than yours.
Decided to go through like pretty large airframes for like future years.
Is this mount?
No, it's not mine at all. It's pre-preg over mandrel. It just looks now. And like it's really easy done and like it made like small parts. Yeah. No, it was decently smooth except for like these tiny ridges. Like it's cosmetic, like honestly, not that bad. So just like stick with it. Didn't have like proper controllers.
Proper checklist here. Look at this.
How much is that GPS?
Your what, sir?
The GPS, S-Red.
Yeah, we have an S-Red GPS as well as a featherweight. Like we're done. Honestly, I don't know. I'm not in avionics. I'm a very much mechanical guy. But I don't think it's prohibitively expensive, like low-key. I'm not quite sure.
So this pair should
Yeah, featherweight, yeah, but it's like an integrated piece. You buy the
so that's
unfortunately, our avionics guys are in here right now. They're like soldering back up. But yeah, it's crunch time.
Is this a hybrid?
We're running hybrid. 2 hog parts and 4 wheels.
Oh, it is a hybrid.
37-foot tower. Damn.
Yeah, the tower.
I don't know, bro. We're trying to get a 67-foot tower just for the lark.
Oh.
How do you start?
And then
In-house, as in our professional machinists have done it. Like we haven't machined them ourselves. Like McGill is very much like hates having their students machine stuff themselves, like which is really stupid. Like we love to like we just have access to like some really small shitty like CNCs. So like some basic stuff we machine ourselves, but just like complex valves, our main actions are made by our machinists. We're using nitrous oxide and paraffin wax.
Problem that it's super expensive. So you take that into account.
Any reason why your fins?
That's a manual dump line specifically for any rocket that has like pressurized. You have a manual dump line in case everything fails, like all your valves fail, your electronics fail, you have zero control over it. And the RSO tongue mover, put a clip there with a very long hook and then pull on it and it opens like a small valve.
Is that just like a suction?
Yeah, exactly. So basically have those airplane panels and we tucked in everything. Just kept it open.
So some of the next steps for us are
basically like exactly the same tools for our airplane.
And that'll help us basically analyze the data and see
Okay, it's kind of cursed. I will admit it's definitely not great fits, but they are sandwich panels. So the reason is that like they're sandwich panels. It's our first time like doing them like that, and so like there's like other manufacturing like issues, and so we got them done. Next year we'll do like a better job at like profiling them better. But they're like really thin. They're like a couple dozen grams each. Yeah, of course.
Damn, bro, a lot of S5 PCBs. Pretty much all the parts.
I'm happy about it. It's like a bunch of like. It's just like a bunch of like all of them and on like all the aspects on like one for
31 kg at 30 kilograms, bro. We're so bad.
well, her brother went to Mac too.
4 cal at 15% stability. Oh, that's all.
This is what?
Maybe I'll take her down later.
0400?
Why don't you take
34.
Oh, 3400.
Very cool. Yeah, same. We're running the same
Same parachute?
Yeah, ours weighs more though.
Yeah, that's one thing.
Same main chute. Our drone's 1 foot bigger. Because our thing weighs 10 more kilograms. Yeah, and they're also going almost double our speed.
It is basically almost
Lift off mass.
12.
30 kilograms.
They're doing 12 sheets of carbon. Holy.
We have 8.
Yeah, we have 18 or so, bro.
No, but 8 at the end, bro.
Good champ.
Hello. How's it going? The day before, any questions?
We're kind of jealous here. You guys are going faster than us. You guys can do minimum diameter.
Yeah. Skinny. Way to go, I guess, baby. I don't know.
We always do minimum diameter, but this year we have crippling problems on the mass.
Crippling problems? Where are you guys?
Arbalest Rocketry.
Oh.
Yeah.
We're running it Ultra 400 also, but ours weighs like 10 kilograms more than yours on 1.5.
How fast are you going? How high?
1.4 Mach and 20,000 feet.
20,000? I think, like, I don't know, compared to last year, like, our rocket didn't change a ton, except for the fact that it's going a little higher and a little faster, but I don't know. There's, yeah. A lot of small rocket changes. It's like the primary GPS thing. Everybody changing a bit. Yeah, like physically they changed a lot.
How many layers of fiberglass are you guys running?
Oh, I actually have no idea. There's a fiberglass. There's like 0 people here that do that. Riley, how many layers of fiberglass? Yeah. Like, you feel useless. Yeah, man, I don't know. I could give you airbrake stuff or recovery stuff, and that's about where I stop being useful.
The recovery is pretty similar to ours, only our drone's bigger.
Your drone's bigger? Yeah. How much? Pardon? Oh, okay. Yeah. Like, I don't know, your mate's 10 feet? Same 10 feet? I'm looking into making a waste of time this year because it was kind of tangled last year.
You packed it pretty good.
It was.
So we have more than that. That's the main fact you can get loads of everything and you get also what it's supposed to that's the problem. This also has like the same signal. It can also fire the drogue in the main, but it's programmed to do it a second after the Raven does it. You're not allowed to do it otherwise. Yes, it's a featherweight at the top as well. And
So
also
it's like separate from like the main avionics thing.
exactly, it's completely redundant. Like we also have a GPS in the main flight computer, which it transmits over. That's the GPS, and then there's the antenna for it. And then, yeah.
This is your antenna here.
Yeah. Right here, yeah.
Oh, right here?
Yeah. This is for the GPS.
Oh, very nice.
Oh, and then the payload stacks on top of this, and just communicates through cameras.
Yeah, free payload.
We got the science department funding every single payload we have.
And algae samples, specific substance, UV light, yeah, red and blue. Yeah, like specific
No, we're worried about our payload wobbling a rocket right now because it's so heavy on the
Oh, you told him, bro. I told him to use Pet
I told him. Styrofoam. Yeah, he knows, he knows.
He knows ball. Michael. Huh?
Humping, bro, you're humping. Hey, yo.
I think you would are the same.
EMU has like 3 different teams.
I said team are the same thing.
No, so we have a control system.
We have active control. They're worried that our flights are using an old motor is too much thrust. So they're making flights. So it doesn't work. It's separated. Proper pillows and proper pillows.
Good.
Yo, better PPE than half the university team.
She's writing the name of our school. Yeah.
What's
Scan this Instagram.
Take the picture and just take the picture. It's gonna do it.
That's so super.
So I need to like go to the QR code.
No. It should automatically. It should.
Just zoom in more.
Zoom in. Oh. No problem.
They're ready for an empire.
Yeah, check the UFT. Check the UFT. Bro, holy cow, the high school team followed us.
Yeah, follow back, bro, follow back. They probably learned our techniques.
Hey, yo. The techniques.
95-pound drive. 10K. That's every 10 pounds you get 1,000 feet, bro. It has to be. I remember them saying that only 10K move.
What?
Yeah, close the ball in. Dry powder connection. 10 foot lead. 3 foot drone.
We're in that separation 0.5 seconds.
That's no closer. That's almost no.
Zapping the pink one. Did you see all?
pretty good.
Did they change their shoots?
I think they print the bulkhead, and then have like carbon fiber plates on top of it.
Copper, actually. Live video, live telemetry, GPS, wireless.
Thank you. Starting that. Yeah, they're ASA. Yeah.
Your coupling is a little
Coupling is could be a little fragile. Yeah. We're gonna see what happens. Luckily, we have a nice camera to catch it breaking.
Oh, to catch it.
Yeah. Okay. No, I don't know. I think
Looks really cool.
we'll see. Yeah, we'll see what happens.
I like the design.
It's done in metal.
Too heavy for our rocket. Just yeah.
Cut your output. I think it's another thing.
200 grams.
We get more funding from science if we get payloads. So we just accept fate and just heavier rocket.
Oh yeah.
Yeah.
What's your payload?
We get
like?
more money from the science part.
Oh really?
We get yeah.
How much you get?
The payload's full money, that's why.
Oh, I see.
So they can spend what they want on the payload.
Well, yeah. Wow, nice.
Yeah, but it's like this. Yeah, that's exactly.
We got a 5 kilogram rocket. Payload weight nothing.
Oh really? 3.5. Yeah, you can lift it. Yeah. I mean, there's nothing in it right now, so. With the electronics and this
Will
experiment.
we all be ready to launch on Monday?
Us? I don't know.
Weather's looking pretty spicy.
Yeah. We're waiting on another. I think Waterloo has a. We need a Montreal.
Now we wait for the vibes.
Yeah.
Water is probably
You guys better have good customer relations with them. We almost couldn't launch because we didn't have a long enough rail.
Oh yeah.
Tuesday last year.
I think we used
The LC rails are actual
we used last
Yeah,
year.
I know. We can't launch on LC.
They need to upgrade the rails also.
Did we buy a $4,000 server?
Yeah, they got.
We'll see.
Yeah, they got a really big brand. Upgrading the infrastructure.
Claude is a part of our team. Someone throw Claude on the rocket. They're coding the flight computer right now. Air start deployment logic. All Claude coded. No, that's a joke. I need to stop saying this. Otherwise, we're going to take a very front little pocket. Thank you.
M3400 and a M1560. 3 green and a 610.
He's like based on some
This is the what average speed.
Well, I know the future. I don't know. On a real note, though, you have to have like this conversation where
I don't know about one. I don't know about one.
So it's like, I mean, I don't know. It's like you said, 23. My life is not one ride. Yeah, this year is just like, I guess you could just like, you know that other stories, that's
Hi, would you like to know more?
How high is the floor?
35,000 feet. And Mach 2.3.
Okay, well, you know, it's like I've asked the fishermen.
Go ahead, you can grab one.
This looks interesting. Okay, I'll grab one.
Maybe it doesn't fit the vibe on your computer.
No. Oh, okay.
Yeah, looks pretty good.
Any questions?
Is this ready to launch tomorrow?
5 minutes.
Is this ready to launch tomorrow?
Better be. Have our last
Every team.
We're very weather dependent.
Yeah, that's the
Yeah.
problem.
So if it's going to be like any like pure passes, it's fine. Well, depending on any like pure passes.
Yeah, it depends on the wind as well.
Yeah.
Yeah,
Oh my god. That's, yeah. Is that entire thing CNC?
If what?
Is the entire thing can CNC?
So it's 5 different pieces.
Okay.
It was all CNC. The fin gets screwed in from the inside of the motor.
Right, okay. Oh.
You got a subway like a walk away.
But there's no
I see it. Okay.
little, and it's bolted on from the inside.
Actually, there was one.
So there's counterboards on the inside so that we put the screws in, and so that they sit inside far enough so that the motor can
It's watched the EDP
into
documentary.
this minimum
It
dragon.
presents it. Yeah. Dude, it was so fun. Yeah. Like, can you walk me through what you were playing?
Yeah, bro, it looks so clean. Better than ours.
I successfully did it. I started down this side.
And they just kind of sit on there. We have one, a spare of just the fin. It's like wrapped up so we don't damage it. This is like just the fin.
That's nice.
And it has bolts that go onto here.
Nice. It looks like so seamless, and it looks like
It looks like it's one piece on.
Yeah.
And it's just the tape.
This is just tape so we don't cut ourselves. Because I've already cut myself on this one. They're very sharp.
It's gonna come off like right?
Yeah, we're not flying with it. It's just for right now.
Awesome.
And
Very
our machinist at Ottawa made these at the university.
Really nice.
Thank you.
I'm gonna keep it safe in here.
We'll see, bro.
That's you. Guys gonna stab himself on the fin, bro.
Twin fins.
Sorry?
Yeah, I'm getting ready for the safety check.
Yeah, we're just gonna get safety check and then we'll see when we actually end up launching, but
And then we put that on the rocket.
Is this the method? Look at this. Spray paint. Spray paint with the sensor.
That's what Iris suggests.
yeah, in the future there are people who print stencils, so we should probably
Apologize.
So we did put like we could have put a clear layer first so I wouldn't bleed as much.
It looks good.
You can't tell from far away.
Yeah, that's okay. That's all that matters.
It doesn't look weird from like launching the like when it's launching. See it work.
You gotta have an amazing live stream view. Nothing else matters.
And what is that sponsor?
Oh yeah, sponsor's good.
Hot aid technique.
It's rocket flying. Get Ronick on that CNC lathe, bro. The guy made a CNC mill and it snapped and killed itself.
You can do it for like $5 grand. Did you guys step in the water with guys?
It's good now. Is yours a two-stage?
No, ours is active control.
Pardon?
Ours is the heavy-duty active control.
Okay, cool. It's a little thing.
Is that with air brakes?
No. I mean, the fins can be turned in a way that becomes the air brake.
Okay, got it.
It can be.
That's really cool.
Yeah, it can be, but it's not programmed to
Got
do.
it, yeah.
No, we didn't. No chambers and fans.
No. We just, we're getting really close to that deadline. We need a fully assembly thing. And we got our place got the date.
Like, we got it simulated.
It's our first time with trying to get modular design, but in the future, because it's modular, we can have
Hopefully it goes good. Alright, well, eventually we can try one out. Pretty good. Are you gonna Loctite them in and stuff?
Loctite. We got steel centering rings here, and then the thrust plate is also a ring right there. So, yeah.
It's proper label here too. Nice.
Oh, that's just because we pulled the motor out and it pulled the compression with it. So.
What is this? What is this abomination here?
That's their ground state antennas.
Holy.
They work really well.
Yeah, it probably works well the worse it looks. That's the thing.
Yeah.
The worse the antenna looks, the better it works. That's
Gotta
fine.
take some.
You gotta Loctite that shit in.
Gotta take some focus.
Oh, they're not in here.
Sure. Oh, look at this structure.
Topology optimized.
Yeah, bro.
Look at this.
Oh, the mass optimizing is nice.
Anyway.
And they have a zipperless coupler too. Zipperless. There you go.
This is carbon fiber. Upper sections are fiberglass to be ring and transparent.
Nice. Yeah, I wish we could have assembly this easy, bro. I stick my hand in half into the rocket. We only seen one hole. Is it working?
You guys flying this year? Sorry?
Everything working?
Yeah.
We're using 03400. We're trying to inspect We're trying to inspect all the other O's. We have a wager on which O shreds this year.
Can't be us.
Last year both the O's shredded.
Yeah, it might be us too, bro.
Might be us.
It's sus.
Looking good for you guys.
This is your first.
How much did we pay for all these? It's kind of like $100 per.
Proper modular design. Hey yo. Is this a custom featherweight here? Ground station?
This is Greg.
Oh, okay.
This is the old name, ignore that.
Ignore that name.
You got replaced.
Yeah, I got a e-ink display. Do you know the ones on the like an e-reader?
Yeah. Like the straight map.
Yeah, so you can see it in the dark or the.
Oh, I see.
In the light pretty easily. Like it doesn't.
No LCD display. That's pretty smart. Yeah, that's pretty smart.
What do you guys run for avionics?
We got SRAD.
Sorry?
Very nice avionics, that's all I said.
Oh, thank you.
What are the different parts you have?
We got communication modules.
Okay. And the whole purpose is
altimeter just for logging data.
It's attached to charge no. Okay, two or
Power module.
Interesting shade.
Tripping safety special? Did you see the hardware?
No, I don't. I'd love to see it. Welcome back, live stream crew. Have you gone all the way around? Was any important sites to see?
You should check on U-Auto.
U-Auto? Well? Okay. What about Waterloo and Queens outside?
And I don't think they're here.
They didn't come today?
They're not out there.
Anybody catch that reference?
Get the sponsors visible. To the side. Sponsors visible.
Bro, we gotta do motorboat. I cut the thing.
How long does that take? Can you do it now so we can go get food?
Bro, you have your own car. Why are you bothering me?
Bro, you're a kid, bro.
Bro.
You're a cook, bro.
Bro.
Let's do this.
Hey.
Yo, Eric, after you're done with the
Yes, okay.
Hey, yo.
Got the insider.
Hey,
The
yo.
insider.
You stay for like unsealing tips.
Does the consultant win too?
That's true.
I guess so. Well, I think that you may go back and this has no price. Robin. Oh, are you free? You're trying to fly, right? You know what? Oh, it's all time. Yeah, what's good, Chad? What's good? Right now it's we only see one of our ops, bro. One of our 03400 cops. Where's the rest of the O's? Where were you guys? We only saw one O. Where are they all at?
Oh, yeah. Yeah, we gotta...
Bro.
Can we go build it?
440.
Let's go build it.
Judging's at one, no?
We're already judging?
Mike, go check judging.
I'm already judging.
That's safety inspection. Check the job.
No.
1 p.m.
I'm judging you, Tom.
1 p.m.
Yeah.
Why are you judging me? Because why not?
It's like 20 minutes.
Wait, do we need all the stickers on for that? Bro, where's Ivor?
Good. We just need the team number.
I approve.
Team
I told him he could do it at the Airbnb.
No, I told him to just put a 3 on it.
Where is he?
John, we might be good.
What else do we need?
We need everything. No, it's basically the 4 up.
Yeah, but no, we're gonna leave it in charge for them.
Yeah.
Okay, let's clean up the fucking table.
Hey, get this.
This laptop.
Daddy Blood Nathan.
Oh no!
Oh, Nathan.
I wonder why.
Fucking garbage. Yeah.
Oh, stick separation occurred. But wait, all the stuff that we put in the nozzle is still there. It's literally Goose 4. Yeah, literally. All the shit we put in the nozzle beforehand just stayed in there. I didn't realize it was a live motor. I'm like, yeah, well, it's been in the like, there's moisture everywhere. The water got into the connectors, everything's shorted. Yeah, fine. It doesn't matter. It's gonna cut things. Yeah, wait until my Carolox rocket and a little residual oxygen.
Michael, would you be able to put your camera away for a bit? We're getting judged soon, so we're trying to like clean up the table. Judged. Yeah. If it's possible, if it's not, it's fine.
Can we put a banner over the table?
I don't know.
Michael, can you, it's still hot. Right now?
How do you get it in there? Oh, you want it out?
Ask me.
They ask questions. But
What is the name of this event?
No. They judge based on the standards set up in the company.
Michael, is there a payload stand anywhere down there?
It's broken.
Oh, it's broken?
What's broken? The payload stand. I don't even see it.
Based off like the story. Over there
We need Gronick. Where's Gronick? How'd it break? Eric, should I assemble the payload bay?
No. Have it out.
For the judging?
Yeah.
Out or in?
Out.
Hi, Ivor. Yo, can you come back to the table? Okay, see ya.
Yeah, I think we'll cover it out. Michael, can you clean up the cameras, please?
Oh, hell no.
Or set the tripod, bro. Just put it on the tripod.
I'll say, can you move to the ground station? Move it outside.
This is so tip heavy.
David, judging tapping like 10 minutes. Can you prepare the payload? Did they want to disassemble or assemble like last time?
Where's the big set? I had pro. Right there. Eric said to not to assemble it in the angle. I mean, they're not judging. They're just judging the rocket.
One grade and one Move this game out.
Bro, they're on the next table, Mike. Judging.
Okay, what else do we need ready me here?
Call Nathan, Ito, Cena. Like, where the fuck are they?
I'll call Ito.
Michael, it is 1 p.m., right?
No, 10 minutes.
10 minutes.
Fact check shoe, it's at 1 p.m. Michael?
I'm gonna double check this.
But it's all little things. It's nothing big this year. Except the big holes.
Yeah, that's it.
Bro, yes, it's 1 p.m.
1 p.m. It is.
It's been What's your favorite hole in the rocket?
Wait, what's this hole for?
Guys, are we team 4?
For your camera.
Wait, 3? Oh, it's just tables. Never mind.
To be honest, you didn't need that big of a hole. But, you probably had enough thermal mass, so just air in here.
Okay. It's
Does this technically work as our manhole?
Wait, it's it?
Does technically work as this?
Well, like, yeah, as long as your system works, it works. I like these. Do these ones actually look down? Like you actually slip in?
Yeah, Monica complains so much about the drag, but like we can't even look at the fucking fins if it's not out enough.
Yeah.
So like, he has to cope.
Like these ones actually look like you could actually look down. Wait, you can see the fins with this. Sure. Have you tested it? You have videos showing it.
No. Because it's a goggle, you just wear it and look at the view.
Does it record itself like...
You're gonna press record to record.
But do you have to transmit and then record on the goggles?
That's 2 options. Yeah.
There's backup recording on this.
No.
Recording on this and on the goggles.
Okay.
The goggles will take me.
Because I know there's some cameras that only like they can only transmit or they can only record. It's like
we didn't get that one.
I'm like, why the fuck would you have that option? It's a stupid option. Of course you want to high res.
You have to talk to your loop.
Good. I'm glad.
Michael, when's the presentation?
$2.15.
Worth every dollar.
It's like 500.
Could have gotten like 2 GoPros.
Nah, GoPro. It's too big. Well, I'll show you that. This is the same.
How much would the jacket be? Like, I'm just curious. How much were the jackets? Were they expensive? Or the hats that cheap? The hats were really cheap.
$1.
$1. And then
Jackets is like...
It's like 20 something.
34 including shipping.
So it's a bit more. But they're from
China.
They don't do that. Actually, I want to ask you, because you're the original creator of this one. What do you see wrong in it? It's not about like maybe the colors or anything, but what's wrong with it?
Yeah, I know. They encode it, they encrypt it.
No. It's hard to tell, no, but there's...
I guess the orbs maybe look like boobs.
No.
Really awkward.
Look at his hands.
No.
So this is inverted versus like this is
Nope. This is your logo and that's the screwed up one.
Tape. I want tape.
the art looks the same.
Oh, it's wrong A.
I mean, I think that A looks really good.
I think it looks really good. The only thing I don't like is the spacing between it doesn't line up this one. But like,
Here's the real question. Does anybody that you call when you reach out to sponsors or people coming to check out the team know how to fucking pronounce Arbalest? Arbalest.
You guys ableist.
Don't accuse me of nothing here.
Yo, can we clear this?
Ableist? Can we get the rocket nice and take a picture, all of us?
Yeah.
We're getting judged apparently in 5 minutes. Where's my laptop? Yeah, pictures later. Where did they go?
Is it screwed in? Screw this in.
Yeah, I know it is. Not now. It's so good. I think it's the best one I've
Here with strengths.
Yeah. Which I didn't. I was like, why are there straights? You don't get straights here, but they explain like added stability. It gives them a little more wiggle room on.
Because it's channeling the airflow.
Just don't look at the straights.
Yeah, don't do that.
You notice how they also...
You guys should do that.
They did a great job.
You don't see all the like colors.
Halen and I don't think I've really, I sanded an area maybe a year on one team one day just to say I did something. But we didn't touch this. This is, they did everything.
That's right.
And barely any, like I didn't go in there, I helped roll, I think, with 1 day with Eric, and he's just been going.
Okay, bro.
Help Auto paint every time, they do a great job. The only time he didn't was on the logo flag. The one guy was like really...
He's irrelevant.
He did never put stickers on. He said that. He's like the other guy, helped you put on stickers, but he never puts on the
Go get some food. That's good.
Photos at 4. Yeah.
I think, no, they gotta go do their motor. You got gun motor assembly? Yeah. No. They actually do it later. Before you add the grease, check how the liner fits in the case. If it's loose in the case before the grease, you need to really do a good job with the grease, or it will take. So it should have, like, there should be some amount of friction going in, just dry case, dry your liner and everything in there. Make sure it works good. Okay. Good, good. And don't, like, a lot of people just slide it in, and then, like, that's it. Like, go in, but, like, force as you're going in. And then pull it out. The whole surface on one side should be wetted with grease on the inside of the case. And coming from the other side,
Screwdriver. Screwdriver.
Greased up.
Back here was into here where everything is decoded and all that goes into the outside display.
This like gets all the info.
Yeah.
What is it? Like,
so this is something you can this we built, but it's the same thing. We just got rid of stuff we don't need. This is an RF module. This is what actually like captures the data and decodes it. This is the FTDI chip. This can tell the RF module, for example, what we're capturing and how to decode it. And then the rest is just resistors, capacitors. And when this light is flashing, it means we're transmitting stuff in. We're doing a demo, so it works. And then the rest is just a voltage regulator. I don't remember if we have this RAM in here or not. Probably no. I don't know.
Try getting it.
Well, yeah.
what's that? Alright, where's the? I need an M4 button head. Thank you.
We're gonna get judged.
Yo, can I get the screw? Give me the screwdriver.
Payload, did you bring your stick?
My stick, the extension? No, I did not bring the extension.
Bring pole, Jose?
The ball, no.
What pole?
What do you need it for?
Poking out a fucking ball guy.
Okay, I put one fastener in.
Okay, hear me out.
It's just going to be on the side. We're not taking any loads. We need to show off the recovery lines.
Yeah, bro.
Eric, should I put this guy onto the nose cone?
Yes. Or no. You can leave it disassembled.
Okay.
Leave it disassembled. Where did my phone go? I can get you a box.
We're getting judged in like 5 minutes.
Why are we getting judged at the same time?
You see Mary on this.
I want to take a photo of them.
Eric, you do that?
I wanted to do flexible.
Which way does it go? Here.
Yo, what's up?
Wait,
Buzz.
There, right there. get one in there. I'll get a couple. Okay.
They're going to be with us soon, so the judges are
Hopefully they're fun this year.
say we're going to be your moral support.
Yeah, sure.
We're going to be we're going to silently support.
I appreciate it.
This mechanism, each fin has its own servo motor, and each fin is able to move about 7 degrees back and forth. That's what the mechanical stops on the inside. There's a pin connected to here, so it's a worm gear mechanism. Right? A 10-to-1 worm gear, so each servo is 62 kilograms centimeters. After the worm gear, it's 620. Not really, because it's 60% efficient, but that's still way more than enough to survive the dynamic pressure in flight. This whole mechanism gets mounted to the back of the rocket. These fins can be removed. Each fin has 4 socket caps. So we put in the back, fins and stay with the long one. For our motor, we're going with a 498 casing and an 03400. This right here is our motor retention. It's Overview. We've got wings here, which work with aerodynamics for roll control. 2 caliber couplers. At our thickest, we have almost 20 layers of fiberglass. Shout out to the avionics.
4-foot drone.
4-foot drone and 10-foot knee. We're using flaps for doing top. Blue Raven for ejection and SRAS for the controls, but it's not going to connect because safety officer. The 2 underfoot for stock is mega foot. SRAS is 3 foot with the 2 shots for that.
Okay, so here we got the nose cone. Essentially within here is the payload bay. If you have the screw, because as right now you kind of see it right now currently, we only have 1 screw fastened inside. Okay, my bad, I thought you did. So I'll take out the 1 fastener we put in, just, yeah, you can take it out. So right now we have this payload bay, essentially almost completely made out of aluminum. So over here it's secured with 6 M4 fasteners, and these 2 beams that hold all the big payloads together. They're secured via 2 M5 screws on both ends. They're all socket heads. Overall, it doesn't have anything to do with the nose cone retention. It right now uses a taper fit for the nose cone tip itself.
What is your mission?
With this one, so basically we have this algae in which we're doing a scientific experiment for. So essentially these algae, what we've known, I think around a year ago, we discovered that essentially that they tend to move away from light when exposed to it, and they also
we'll do it under certain chemical reactions. So as a result, what we want to do is that on this side of the payload, we have a camera and an ultraviolet light. So at apogee, these algae will be at 0G for like around 3 seconds-ish. And at that moment, the ultraviolet LEDs will go off, which will then cause...
Have you seen Project Hail Mary?
Yeah.
So you know how in Project Hail Mary we
Yeah, it's
have
like
the
that.
astral base?
Yeah.
Exact same thing. But these
No,
cells
not
basically,
quite.
these cells, right, they can't move on their own, but we discovered with these UV light and gravity, like,
But yeah,
so we're just getting rid of gravity.
So they'll glow in the dark essentially, and we'll capture that here. Then below here we have a load cell and a piezoelectric cell. They'll they'll give us the measurements on the axial loads and the vibrations. And like he said, it is kind of like Project Hail Mary, because like in the movie, the astrophage, they move towards the light. These algae, they move away from it essentially. And then above here is the cosmic film payload. Essentially, it has like a little film that will change color when exposed to cosmic rays. So as we go through the atmosphere and change in altitude, this cosmic film should change in color. And so we will have a before and after.
3 experiments.
Yep.
We also have one cosmic film that's 10.
Yep. This will be attached to the recovery lens right here.
So with this one, it's a little different. It's the cosmic rays are going to penetrate the heat away, and then
Regarding rocket decals, we've got this is our team in here, Arbalest, approximate center of gravity, center of pressure. We've got rocket in here, up on this tube, sponsors, contact info, and team number, project number.
I guess the mandatory question is, why did you decide to go
Yep, so past year, we've always gone for altitude, and we've been on the rocket, something on the rocket side, to drop them out. But this year, we kind of went a little break from the whole optimized stable stuff. So, like, you know what? Control things, so you must work that. This whole mechanism is designed so you can do things off the floor. Size and work that. And the roll control is really just going to be 2 pins moving back and forth. The aft spin is chosen because Goose 2, one of our rockets in 2022, already has Canard control pins. And honestly, the big Canard control. However, Canard control rockets are really hard to model because of that. And basically, the air will have it. You get it back to the top of the water. And this is a way to put off the bins. And we have a whole simulate model that models the roll experimentally so that we know that it will work. And we know it's a result because we've rolled a bunch of test rockets. We've rolled 9 test flights, and we've done roll control. With this mechanism, we didn't get comfortable working with this mechanism, we've got to work on this one. Yeah, especially if you drop the window. This mechanism, they have very little play and stuff, right? So you can try to like rotate it and stuff, right? It's not going. They're not back to everyone, but this is the worst one, right? Unfortunately. But they're all pretty good at passing things correctly. They can't be back to that's a super important thing, right? So no matter how much force is going on to the plate, they're not going to move unless it's on top of that, these shafts are at the fin center of pressure at max speed. So to minimize the amount of torsion on and torsion on low on.
I guess the second mandatory question is like, how do you separate
So there is one is a mechanical stop on the inside, right? It uses a pin that's attached to the gears on the inside, and there's 2 stops. They cannot actuate like more than 5 degrees. I'll say exactly that. On top of that, these servos are special spark servos. can talk about the size. I think it's on the sizing is based on our so we have the whole rocket ship, like all the way on the wonder. These wings can create roll density. Like right now, these fins are way too expensive. I don't know if you've seen a lot of or any stuff you see a lot of the chargers trying to do, right? That's what these are here that we have access to the rocket and to stop one or two things that are out your wing to cause the rocket to roll as well. But these, as the rocket is rolling in the air, it's not the rocket to roll as well. So prevent that and also helps it to roll. Drag? It does feel a little bit more drag, but we're not trying to go for a super optimized rocket.
It's worth mentioning that our profile down here are making design for the rockets that we want a 5-inch diameter, which is absurd at all. But with our chosen basic and the servos we want, there's physically not enough room to simplify this profile. So we designed this profile to have it where it's a very minimal effect on the cross-sectional area.
Hey there, rocketers out in the arena. We'd like to invite you down to the stage for our next talk. This one being given by Arbalest Rocketry, which is going to present the awesomeness.
The cross-section of the it's just a quite needing to be a 6-inch diameter rocket. Stepping it up and increasing a lot more, much longer gravity.
It was 6,000 rocket, and it was going like 7,000, 8,000 feet left. Oh, yeah, this is at the half of the rocket. The motor AC rests up against the gap. And for our motor retention, we have a bulkhead right here where we have a
wedge lock, washer, and a cap and lock.
Inside? Yeah.
The bulkhead is aluminum, 61, 61 board rail, and we have a bridge lock on the floater. We put a wedge lock washer, so we don't aluminum, and then we work it down, and we put pins in it.
Is it also epoxy or just
The threaded rod is red lock pedal.
Yeah, like we can make it also like plug in and we can't
As we saw the four holes on the outside, right? We put it on thermal wiring that goes to rocket.
Or a simply. So, it is up a little bit have a custom nylon. The manufacturing is a little bit of a pressure. You have to take it a little bit and take it out, you put it in a small rod, put a surmount here, so you actually all we get to this
talk us through your avionics?
Individual batteries for all our and the service. 4 and
Have you guys tried battery life and the amount it takes to?
So battery life cost is around 40 hours, and apparatus is around 45.
Is the camera also connected to the same batteries?
So the cameras connect to the
Okay, so it's basically integrated. Doesn't it suck too much energy? Charge everything.
No, so like actually the camera has power.
Okay.
Like the main reason, the main problem with the camera is the overheat
looking at the
We'll be on recording, and we're going to be getting live collaboration.
What about redundancy? Like, do you have another section with, I don't know, the school where you have GPS or...
Also, you have two GPS on here.
Yeah. Okay, but everything's in there, right?
We have also flown this flight computer.
Yeah, so we flown the flight computer, like aircraft flight computer on at least 3 times.
Now, take us through your recovery. So for recovery, we have a 4-foot, 0.97 CD electric parachute. It's connected to our triplets and swivel. We're using 3 bags, so what we're going to do is this is connected to our recovery line, 2 feet off our rocket airframe. That way, when the parachute comes out, it'll pull the bag out. So that's how we'll pull the parachute out. We use black powder 4F. Here's a commercial for it. This is tubular nylon, and we have 40 feet here and 50 feet for the We also have electrical tape for the black powder goes off. We use nylon. So these are not so we have wound it extensively in and then that's disconnected to our the drone's connected to this U-bolt. This is a 5/16 U-bolt. 5/16 U-bolt. And for the main, it's 3/8. We will be lock tying some of these bolts down. We have, we have multiple seconds, but this is our
Have you guys rehearsed many times?
We actually flown a smaller version of this rocket 3 times already.
Yeah.
So we know how to
We've flown 9 times this year, so we're just optimizing our plans until we can, really getting perfect.
Usually does it take you to put it together?
This, yeah. 11 minutes. One, no, pickup.
This is like the same one.
Yeah. I just want to like my
Okay.
Yeah. If you were on my side, what would be your biggest concern?
I think there'd be some stuff with the airframe, in particular our nose cone coupler. It ended up being a little bit too thin. Just kind of some manufacturing defects. But it's also a heavy payload, and we said the same thing with the safety team. So that would be like kind of a weak area.
Our nose cone gets quite heavy, so the lower air from the rocket has quite a long rocket.
Yeah, so our most high concern is the nose cone. Ray told us about the AOA and make sure the AOA is stability on the rocket front.
So we also have a minimum, maximum weight position, right? Because we don't want any sort of that what is the number that we
which is I think only 400.
What about the name? Because you
Oh, the main? So for the main parachute, we have a 10-foot, 2.2 CD rocket mounted parachute. It's a toroidal. With swivel, it's connected to our main line. This main line is 50 feet. We have along it, there's a point where our recovery payload, this one, attaches to the line. That way when the whole thing comes out, the payload will be around like 10 feet off the nose cone, but it'll still be in the air. For the main, we have 3/8 inch U-bolt here and a 5/16 inch stainless steel one in there. The nose cone is not going to experience that much force on the shock, so this one's upsized.
Yeah, okay, yeah. And do you plan on folding this? Is this the final?
Yeah, this is already folded. We don't want to unfold it. It's really hard.
Sure,
I can take a minute to talk about all the fiberglass manufacturing. So throughout the year, we've been, I feel like, countless hours of experience our prototype rockets, and like I feel we've really locked down our methods. So we have like standard, mantle tubes, and a key principle when we're actually manufacturing our tubes is we have jigs for constant tension, which gives our tubes like a really tight, although thin structure. All the tubes you see, so we have bottom inner, bottom outer, bottom upper, and outer upper. Yeah. Like 2 and 2, each are 7 layers, so 14 total, give or take. Around the wings are our last steps in our manufacturing process. These wings here are 10 plates that were water jet cut to profile. They were mounted just directly on with epoxy, and then we did proper tips. Some other practices we always follow is like standard surface prep with sanding, acetone, alcohol to get like the best possible epoxy bonding. We really worked our edge surfaces to have like full and maximum contact for force transfer. That goes to the upper coupler and the couplers that you don't see in the rocket. Possibly the most interesting piece of manufacturing we had at the bottom was this weird cross section I was talking about earlier. It was all done layups, and it's about 9 layers. It's slightly less in some places, but we have a inner tube, as we call it, to give it extra support to connect it to the rest of the tube. So I feel very confident how we created our aerostructure, meeting the needs that active controls require in aerodynamic forces. That's our problem.
Because if you want to do like non-control, you get like 10 degrees, 15 degrees angle of attack. So you have to make
Oh yes. So we have centering here, aluminum to meet the requirements for like metal aerostructure components, distribution counters into it, and then our other launch plug onto here, and then we're gonna have one additional centering ring on the inside. So even this does act as a centering ring, so it's already supported at almost the very top of the motor casing in the very bottom. Yes, this was custom made, manufactured at our school. It's stainless steel, and we checked the fit on the extrusion, but in the case where there is like some other obstruction in the trail, which maybe it would have a different layer here, colliding, we're going to have some space for it. Yeah, I'm assuming.
Every single thing on the rocket that you see metal is
Yeah, we've actually flown with pre-printed versions of these LUDs successfully, so I'm pretty sure stainless steel is pretty good.
last year it was smaller on a heavy rocket.
What about you?
Okay.
Ground support. Oh yeah, so for ground support we have an Ezra telemetry board that is right now in the AV bay. This is a smaller version of the board. You can see a radio transmitter which is talking directly to our flight computer. And the main purpose of this is to have a backup of all our data. Can you press the enter key on that one? You see here there's a link lost.
And once we start reading a transmission from the rocket, we get a confirmation that everything's good. And we start reading velocity, acceleration, and some of the data. It's all logged in this file right here for future, for comparison with the flight data, or to recover launch data in case something goes wrong with the flight. And yeah, we are using 1916 megahertz. We're using this module is frequency coupling spectrum, which means that we can pretty much choose our channels as long as what's available on the site. Right now we have a full spectrum, which is between 900 and 930 megahertz, but we can change that according to what's available at the moment. We have like 100 foot of cable, which is in the box right now, but it's a directional antenna and a pole, which is going to be mounted on the antenna, looking like a 2 meter pole or so to go past the vegetation. But all the system is designed so we get at least 10 kilometer range. So based on raw power alone, we should be able to clear 10K, but we are not taking any chances. So, yeah. And yeah, all this is running a Raspberry Pi, custom firmware. This is meant to be a first iteration in ground station. Future, we are going to incorporate liquid or other projects in the future. So all this is scalable, running Linux in the Pi, and yeah.
I'll take a moment to mention a lot of the paint job. We take lots of pride in how we do our paint work. So we have extensive surface prep. Like pretty much an extreme amount of sanding to how we get the tubes to feel like that. And we actually even send our tubes out to a paint shop. Where they get pretty much like luxury car grade paint. Ferrari red, all with a clear coat, and honestly, it's turned out great for us.
Like that.
Do you have any like going back to your ground recovery? Do you have any concerns with that 10 out?
Yeah, and that's why we are not taking any chances. We went because there is going to be a little distortion to the rock inlet for solidifying the whole AB bay. We got the distortion, but we have accounted for in that the possible loss with the power. Very much we initially went there to use like a maximum because we had the power for it, but like to compensate for any deviation, and this is a spread spectrum technology. So even if our RF wave gets distorted a little bit for the extra effects of the metal, we should be able to pick it up no problem. And like I said, we have a little bit of antenna. We have like 10 dB in this antenna just to make up for whatever loss that we might experience. Yeah.
I sent back yesterday with safety.
Like here? Okay.
We only did it this morning.
Yeah.
That's right.
So those jokes better work.
What they said during today's interview is that or even like our SR recovery, they claim this is like half a kilogram of wire and half a kilogram of thread. And we've done testing on the mechanism, right? At maximum pressure, half an
That's a pretty good shot. It's fine. I was talking, I accidentally pressed the button, I just rotated it for a second, and just my face, and then it goes back to close.
So if I gave you guys a magic wand, because you can change 3 things on the rocket, what would you do?
Yeah, I was gonna say the same thing. Okay, that's one use.
Oh, that's one use. Yeah, that's what we will. That's one use.
What happened here?
definitely do some mass optimization. We're quite a bit over our max budget.
That is the mass
Everything is a little crazy.
Past my safety.
Yeah, so one we have right here, now this seems like a funny shape, and I should have mentioned it earlier, but our camera here, it runs extremely hot, it's at 4K 120 frames, and so we like to say we have like a jet fan going in there for air circulation, and it's like if you go on the other side, it's slowly fascinating. It's kind of like a grin, decorative, that kind of
So this is enough magic for the round. With this, and we have one of the camera mode that was redundant, and now we're getting
What is this made of?
this is just being put in. And then for the bottom two, it's, there's lots of air gaps around the turbo.
Hey there, Rocketryers out in the arena. Once again, we're counting down.
Oh yeah, nose cone? It'll just go through here.
And they're going to be putting on a spin casting method. This one of those that was all the higher runners.
Sorry. Okay. And last question is this
Is it worth mentioning to you that we have a crate for the rocket?
Yeah.
We've lost points for that.
We lost points for that. Oh, okay, okay. I thought you built the crate and you lost points for it. Okay.
Those points come later. Eventually. I do have one question. Have you guys read our FDR by any chance? I did. All of you, if I may. I didn't read it through a judging perspective. Like I read it because I knew I was going to be judging. Even if I judge it, I wouldn't be able to say. But I liked it. It was very informative. Like a pretty good overview.
The only thing I would say is mitigation of the risk was really, I don't know how to say this, but it's like you invent this product that could happen, but I didn't see them fitting or
I didn't write that, bro. I did not write that. I love my train. It's fine to cut me off, but that's for like we're actually leaving. We're done the competition. We're gonna put it on the rail. We're not gonna launch. We're gonna take it off. We're gonna look at the live streams. We're gonna come to the cameras. Be like, what do you guys do? It's like we're gonna tell the camera people we came, and now we shall leave.
So, motor build or what? Motor build or what?
Ronix presentation.
Oh, right.
Where's Ronick?
I'm looking for Ronick too.
Okay, he's not the next talk, but the talk after that. So he should be getting his slides over to the...
Okay.
We'll find him.
Not the next one, but right after.
We'll find him.
You guys are all ready to come? And you're going to cheer, right?
Yep.
It's important.
Where's Ron?
I don't know.
Plane is there apparently.
Yeah, that's what I'm saying.
Meet me here.
When you get to Northern College, it's at Northern College, right?
Yeah, Bay 3.
Go left. Do you remember?
Who's going? Can I join?
There all night.
Go last.
Mr. Meeker, can I join y'all for the motor assembly?
Enjoy.
Okay, it's okay. Give David a I actually really want you to drop it.
You learning lots? Yeah. You enjoying your time?
Yeah.
Next year will be like you getting inspected, no?
Yeah. You hear the motor comes with an O-ring, right?
Oh, I didn't even see your guys' butt. Hey, where is he? Nathan. See this launchman? This is what I pictured. That's what I pictured in my head as a water. It's okay, this first iteration was like that. That's why I envisioned in my head. I was like, yeah, we'll do that. And then we kind of went kind of other directions a little bit, but still, it's beautiful. Good part. Whoever made it.
Say, bro,
Jose.
You could probably like round the edges to make it more sharp when you need it. But like there's.
I'd rather wash it honestly.
Here's this.
Not me. That was David, bro. No one's coming from there. Look, everyone's gone. Like an hour. Yeah, you guys are missing
Jose, I was in charge of the camera for that bit.
Yep.
And while you were talking to them, I actually pressed the button. And it just shows it reflecting, looking at my face and then going back to I don't know. No, I know that's
Are you staying the same?
3D printed grid. You should do these in like different patterns, just for funsies. You could have like different. No, why don't you make them the little hot dog guns that you Yo, you should have done a ton of hot dog guns. Where? Why'd you put it underneath?
Let's see, ground station.
Yeah, what else did you think?
Oh,
Basic, that little connector thingy that's a plastic motor and this is an integrated controller and transmitter, so this is like a single itself, and there's also the TC that's the complemented you over there.
Developed that?
Sorry?
You guys developed that?
No, this is an off-the-shelf component. The rest of the board, yes. The blue one is used by it's a module. The rest it was ours.
Is that like an SM32? Sorry? Is that like an SM32?
No. No, this is it's kind of DG. It's an XP module. It's a radio controller, so it takes information from the whenever on serial whatever, and it sends that information over radio. So our receiver over there is the same module, just like the bigger development kit, which is over there. So we're running that base station over there. But yeah, this is not like an STM in the sense that it's not general purpose. It does have GPIOs like that one, but you're not really meant to use it that much. You can use it, but if you make it for controlling like a power station or something along those lines, not really for like general purpose, like for example TNC or ESP or whatever, you know.
I'm the high school team, part of Turner Campus.
Oh, sorry, man. Sorry. Did you? Okay. Did you understand what I'm talking to you? Okay, perfect. Yeah. So you're with Alisa? Oh, you guys are both the RF? Or?
No, she's RF. I designed our instrument.
Oh, gotcha. Oh, the guy you want to be talking with, he's the designer of our custom controller. You are in the flight computer team, right? You guys are using an STM32. That's 4 or 7? You guys got it works with your sensors? Are you launching? When are you launching?
Kind of tricky situation. Hopefully tomorrow, but like if you want to do it later, it's going to be tricky because of
yeah. Thursday looks like it's going to be better now. So there's probably a window in the morning there, but yeah, Wednesday and Tuesday.
So late though, we won't get any
He's one and done. Or, I mean, you can do Monday and then try again Thursday if anything goes wrong. But yeah, if you want to learn about actual flight computer controllers, he's your guy.
You guys get judged here?
Sorry?
You guys get judged? Yes. You know that guy, Robert Bernard?
Oh, Robert Bernard?
Did he ask about like headshot codes?
No. Like, you don't do anything like that? I
I looked online, I was like, what's the number one aerospace exam? What does that mean? Who said that? Isn't that the way conspiracies work? So we have to listen to that news and they listen to their news. Who's the best ranking system for university? Like, if I said who's the best aerospace university in Canada, would you get yours? No. I swear, Google. Apparently we're number one, and the dean does say it, but like I want to know where that list is because when I did research, I don't have your university. I can't do it.
This up for
We don't have aerospace.
told me I was number one. All those ones can go. Screw them. That's good. But do you think this stuff would help towards that ranking? If they have propulsion cores, and then maybe aerostructure cores.
I don't know, like
composite materials. I know we already learned about it, but like working with it, like when I took composite materials, I didn't know exactly what would be going behind making a fuselage of a rocket. That's for sure. That'd be cool. Like, and you know what? York's rank. So I think they need to give us a little more money.
Yeah, that is true.
Just a little bit.
Broad study, right? Like citation.
Yeah, exactly. Well, I was going to say, it's not important to the students in terms of what they do. It's like
that did become a mistake.
If they're international,
Well, come collaborate more. I need help here. And then if you get cited on it, then York would raise more ranking professor helping thing working with liquid oxygen. Student. But it's a lot of, it demands a bit of time.
no, I'm just every time someone says,
There's a source out there that's saying different. Just one of them out of 50, but there is a source. It's the York paper. It's like
you switched it.
Just initials. Just initials on the box. That's all I need. It says I was here. Oh, okay. Daniel. So is this your lunch? Yes. Lunch or recovery? Well,
I forgot the actual name. EPS. We also have telemetry radio to get our data and stuff.
So we're going up for one.
Yes, hopefully it is.
So when do you launch?
Tomorrow, hopefully. If weather permits. I think
they've already put the rock.
Can you share your map to the
Hello, I'm doing good. How are you guys? Okay, kind of random question. Would you happen to have a micro SD card that was worth a shot? Or not an extra one? We just want to see if our flight computer is actually sending data to an SD card. So like we literally will just plug it in, see if there's data on it, and if there's data we're happy. Like, oh my god, no way. Please do not. No, I'm literally gonna run the test and then I'll give it right back to you. Some Microsoft stuff. It shouldn't care. I don't know what it's gonna do though, so if you have anything important on it. Oh, maybe not that one. We'll give it right back to you.
These SD cards cost expensive these days.
We'll hope it doesn't do something crazy to it. So.
Yeah, no explosion, no explosion.
on that left-hand side of our system, such that we might be able to directly have it pour in for further funding.
Test. Test.
Can you hear me now?
Question. I just want to know how you check for things like cracks and stuff like that in the finalized wax to make sure it didn't like do that pretty quickly and stuff like that. How do you avoid shrinkage? I know you mentioned you avoid that, but in our experience, paraffin wax, it shrinks quite well.
So, as far as shrinkage goes, we're okay with it shrinking internally, so long as the outer geometry remains the same. Just essentially, of course, we'll definitely make sure. And then, as far as checking for defects and cracks, started our testing just because it's easily repeatable, but melting the wax back down. We would just take our filterings, take it out, and then just honestly get a good idea of where everything's at. All right, thank you, everybody.
Okay, thank you, Dylan and Ethan. That was great, and great questions. There's obviously a lot of interest in your work, so thank you for sharing that with us. Our next talk is by Arbalest Rocketry. We're going to take a very short break, and resume at 2:15.
Yes, I need to change one thing quickly. Okay. Does your presentation have video in it?
No, but we have like a QR code if somebody does.
That's fine.
Hey there, Rocketeers out of the Air Arena. We'd like to invite you down to the stage for our next talk. And this one, I really, one of the things I love about Launch Canada is
I need to know if I can set up audio.
Okay, do I need to give you my laptop?
Yes. Can you set it to make sure it doesn't go to sleep?
This is the first student rocket I've ever seen with strakes, and it's because this talks about active control, where they're not actuating canards, they're actuating their fins. So come hear about that, because it's dope.
That should be in like power and battery or something.
Power and battery?
Yeah. And then there's going to be a clicker up on the stage, and you'll be able to control your slides yourself.
Okay, perfect. Power, sleep, and battery settings.
Yeah. And then just set it to not go to sleep.
Power, sleep, screen, and heart rate timeouts.
On battery, just set it to
3 hours.
Or you have to do it to the on battery one.
Oh.
Yeah, set that to
3 hours.
Oh, beautiful. Thank you. Okay, that's okay. I was actually going to ask you about the clicker. So it's on stage. I just want to see it before I use it.
Yeah, so you can see your slides on that screen.
Okay, perfect.
But if you want to give it a test.
Okay, this is really easy. No, it's okay. This is perfect.
Okay. Yeah, it's been working for everybody so far. We haven't had any recommendations.
Thank you.
Yeah, let's wait to start right at 2:15.
Yeah, that's okay.
is by Arbalest Rocketry from the Lassonde School of Engineering at York University. Our presenter is Ronik Jagdev, here to tell us about the first attempt by a Canadian student team to test a rocket equipped with an active roll control system supported by onboard video and flight data. Can we please have a big round of applause for Ronik and Arbalest Rocketry?
Thank you, Robin. Hey, good afternoon, Launch Canada. My name is Ronik Jagdev. I am the mechanical team lead and the controls team lead at Arbalest Rocketry. Normally in the past few years, Arbalest Rocketry has been working on these two-stage rockets, and we haven't done anything different other than two-stage and working on optimizing our rockets. So this year we decided to do something different and work on a controlled rocket. Okay, so what will we be covering today? Well, we'll be covering, we'll walk through the development process and how we develop the system. I'll be discussing why active control is useful for and why conventional rocket simulations don't work. From there, I'll cover the fundamentals of rocket aerodynamics and how these forces and moments can be modeled in a full 6 degree of freedom simulation. Then I'll talk about how our guidance and control systems work, including the control architecture used on our rocket, and I'll end with our Blue Jay test campaign, which was our series of rockets that we used to fly and test our control system. Okay, so just some background this year. We flew 9 flights testing out our rockets. We worked on our, our minimum diameter rockets this year, and active control really stood out to us because it combines aerodynamics, simulations, electronics, mechanical design. It combines all of our sub-teams together into a new project. So why do we really want to do roll control? Well, roll control is super important because an uncontrolled rocket can spin out of control, and this is called roll pitch coupling, where the roll rate of your rocket matches the frequency that your rocket stabilizes. And this rotation, it can continuously rotate around the vehicle, and it can do like a corkscrew motion, and this can cause shredding, like the photo in the middle. Limiting roll also improves the video quality. That's why we had spin cans in previous years, was to keep the rocket from rolling, and and if the rocket spins multiple times in 1 second, it can make it really difficult to interpret what's going on. Okay. Conventional rocket simulation software like OpenRocket is designed to predict things like altitude, velocity, and trajectory. But for active control, you need a lot more. You need to be able to simulate the forces that the fins are creating and create a full 6 degree of motion model. We also need to make a simulation that lets us accurately represent our control system and our control architecture, including things like dynamic pressure and gain scheduling and a bunch of things we'll talk about in the next slide. For our flight simulation software, we decided to use Simulink, and Simulink is a graphical simulation environment built into MATLAB that allows you to model complex physical models using these blocks, kind of like Scratch. Instead of solving every differential equation and every equation manually, each Simulink block represents a part of the system that Simulink calculates over time. For a simulation, we separated the model into 2 main sections, the flight computer and the rocket plant. The flight computer is everything on the inside of the rocket software, like the IMUs and the guidance code. And the rocket plant is basically everything that you would find in OpenRocket, like the aerodynamics and such. I won't be covering the flight computer much today, as I'm more on the mechanical side, but I will be covering the rocket plant, which is basically a virtual representation of the physical rocket. It's very similar to OpenRocket because it has everything, including the aerodynamics, the environment, thrust and gravity, but some things that we added were the servos and some custom aerodynamic models. In the simulation, we treat the rocket like a rigid body. So each component has its own forces and moments, and most calculations are calculated in the rocket's body coordinate system. And if you wanted to have forces such as gravity, which are in the Earth coordinate system, you have to have special vector transformations. So the most difficult part about creating the simulation are the aerodynamics. The aerodynamics of a rocket are broken down into individual components. So for all of you that have used Open Rocket before, it's basically the exact same thing. You know, you have the nose cone, you have the body tubes, the fins, the boat tail, and each component contributes its own aerodynamic forces, which are then combined to compute the total aerodynamic forces on the rocket. The two main forces that we're concerned about here are drag and normal force. Each component has drag, which acts axially, and also each component also has a normal force, which acts perpendicularly to the rocket and to the airflow. This becomes important when the rocket has some sort of angle of attack, because then these forces act in different locations along the vehicle and they generate moments. To calculate these forces, most programs use some variation of the Berryman equations. These Berryman equations were developed by an engineer at NASA, James Berryman, over 50 years ago, and they're used to calculate aerodynamic forces on small-sounding rockets. These equations provide a relatively simple analytical methods for computing the rocket's center of pressure based on its geometry. And in our Simulink model, we follow a very similar component-based approach where each aerodynamic component, as you can see on the right side, is modeled individually and its forces are added together. These are calculated based on things like Mach number, angle of attack, atmospheric conditions, the vehicle geometry, and then these are summed together in the rigid body dynamics model. It's important to remember, though, that Berryman equation is still just an approximation. I was talking to another team here yesterday, and their Berryman equations were off by a factor of 10. So it really depends on the geometry of your rocket and what Berryman can capture for you. Yep. So, like we said before, each aerodynamic component on the rocket has a drag force and a lift force. Drag acts opposite in the direction of motion, and it's calculated using 1/2 p or rho times velocity squared, and this is called dynamic pressure. Basically what dynamic pressure is how much air and how hard is the air pushing against the rocket. The second major, and then also there's the drag coefficient and the reference area. For our simulation, we based our coefficient of drag on Open Rocket, and Open Rocket uses the same reference area for all components on the rocket, being the body diameter. The second force is the normal force, which acts perpendicular to the airfoil. It's very similar to drag force in the way it's calculated. It still has a coefficient, except the coefficient isn't the drag coefficient, it is the normal force coefficient. And that can be found using the normal force coefficient derivative. Basically what the normal force coefficient derivative is it's calculated in whatever software you're using based on the Mach number and angle of attack and the geometry of your part. In our simulation, we get this straight from Open Rocket. Open Rocket has a great feature called component analysis, and from there you can extract all of the coefficient derivatives for all your components and plug them straight into your Simulink simulation. This value isn't constant for every situation. It depends on the geometry, and it depends on the geometry. In our simulation, we calculate all of the normal force coefficient derivatives and use those to calculate the normal force on that part by multiplying it by the angle of attack. So here's just a quick Simulink model of how we model our fins. It has the normal force, and the drag force in there. And these basically are the same things, right? That is the normal force equation, and this is our Simulink representation. Okay. So once the Barrowman aerodynamics are modeled, this is where it becomes important for roll control, is using those Barrowman equations to determine the size of your fins. The goal is usually to make the fins large enough to require a high enough stability, but for roll control, a larger fin area also increases your normal force coefficient derivative, which means the fin generates more control authority than what your rocket really needs. So bringing this all together, a larger when sizing the fins, we should look at how quickly the simulated rocket responds to the roll angle. And on the left is a kind of what happens when you have a big fin. There's a lot of oscillations, and this is because of sensor delay and backlash, sensor delay and backlash mostly. And we want a fin that gives a fast and well-dampened response while keeping the required fin angle low. Anything more than 5 or 6 degrees and your fins are probably a little bit too small. Anything, like for our fins, we have drag separation at about 7 or 8 degrees, but this can depend on all sorts of fin geometry. So that's the aerodynamics portion. Now we're going to be talking about the controls. Controlling a rocket is difficult because the system's constantly changing throughout the flight. Unlike a simple mechanical system, a rocket is highly nonlinear, meaning the relationship between a fin's torque and the fin command is not always constant or proportional. One of the biggest reasons that control authority changes throughout the flight is because of the aerodynamic force on the fins. It highly depends on dynamic pressure, so your control system will need to have different values at a low Mach number compared to a high Mach number. The aerodynamics themselves are also very hard to difficult because Barrowman equations and other analytical methods or approximations, especially like in the transonic region or at larger angles of attack. Because of all this, a single PID controller with fixed variable gains is not enough. A controller tuned for one operating condition may become too weak or too aggressive depending on what Mach number you're traveling at. And this means we require some more advanced approaches. So Arbalest Rocketry uses a cascade controller, which is basically 2 PID controllers working together. It uses 2 control loops instead of 1. And for our roll control system, the outer loop controls the roll angle, while the inner loop controls the roll rate. And this is because if you look at how a PID controller would work, you would need a set. The outer controller looks at the difference between the commanded roll angle, and the inner one controls at the actual roll angle. So it's like the outer, this is a simplified view. This structure is useful because the fins do not directly control roll angle. Fin deflection creates like an aerodynamic moment force, which creates a roll moment. That moment produces angular acceleration, and which integrates into roll rate, not roll rate directly. There's multiple layers of dynamics, so you can't get away with one layer of a PID. A cascade controller separates a single PID commanding roll rate can therefore be difficult to tune because it creates fast motion while also dampening that motion as the rocket approaches the set point. A cascade controller separates those jobs, so the inner loop controls the roll rate, and it's basically saying what roll rate do I need to get the rocket to a 0 degree angle, and the outer loop basically says, okay, command what roll rate that I need to get to that angle. And the last technique that Arbalest Rocketry uses is gain scheduling. And what gain scheduling is it changes the values of your controller throughout the flight and throughout wherever the conditions change. We tune our gain scheduling to dynamic pressure, and because control authority is strongly related to it. At low dynamic pressure, the fins generate relatively little force, so the controller needs to command more aggressively. And at high dynamic pressure, the fin deflection produces much more force, so the controller must be reduced to avoid overshoot or oscillation. This is also used to tune the controller around one reference condition, rather than tuning it through all the different points in flight. Okay, so that wraps up the control section. Now we're going to be talking about the rockets that we flew this year. We had 9 flights with 2 successful roll control attempts. This is the Blue Jay series. Blue Jay Mark 2 is on the left, and Blue Jay Mark 3 is on the right. Each iteration we improved on a certain part of our rocket. So Blue Jay Mark 2. Blue Jay Mark II was not a success at all. The servo motors had way too much play. The rocket did not even fly straight. The stability wasn't great. The camera didn't work. And to improve on this, we created Blue Jay Mark II, again, V2. And in this case, the servo motors, they still had too much play. There was bad phenomena. We at least got some footage, and we got really good state estimation data. So our electronics lead was able to tune his state estimator, and we got really useful data. Our third rocket, Blue Jay Mark 2.5, is really where we were able to start getting things rolling. We were able to get working roll control. The first launch, we flew, and the gains were not tuned. The rocket did control itself, but it was overshooting like crazy. So what we did is that week we took the data from the rocket, from the overshooting, we modified our simulation, we changed the values of the aerodynamics, and we flew again next week, and then we were able to get active roll control working. We flew it again twice just to get that video footage, and it was a complete success. For this flight, we did not use the cascade